This is 6.1.2, the first example. We're now going to use the DTFS of a periodic signal that is 8 samples long. This is the sequence from x of 0 to x of 3, they are of value 1, and from x of 4 to x of 7, their value 0, and they repeats infinitely. So this is a periodic sequence with period 8. This is a sequence of one period, and to perform Fourier transform on this, we of course take the DTFS. This is the equation of the DTFS. Basically, Ck equals to 1 over n. In this case, of course, we can replace n by 8. The number x of n is x0, x1, x2, x3. So we have x0 to x3 here. And then we replace this by 8. And then we can calculate for k equals to 0 to 7. So we replace this as well as k here. And for different n, we are using this equation. You can write a for loop and you can calculate Ck's using this equation. Now, in MATLAB and in Python, they provide an equation or a function called FFT. FFT of x is a fast version of DFT of x. Remember, DFT of x is this equation over here. And to relate DFT to DTFS, remember that we go back to our previous slide. This is the DTFS and this is the DFT, and they are related by 1 over n of the DFT is DTFS. So what do? We write this equation. 1 over n times the FFT of this sequence is how we calculate Ck. Okay, so you should do that, as well as you should write your own routine to solve this for yourself. This is the answer. It will give you C0 to C7. In MATLAB, you use index 1, therefore the last element is index 8. This element is C0, this element is C1, and so on and so forth, C2. So remember, all this in the frequency domain representation, they are complex numbers. Typically, we don't write it in rectangular form. We'll convert this into magnitude and phase. So with that, we now can plot the magnitude and phase. Look at the first number, 0.5 plus I0. So the first element is 0.5. So this is C0 magnitude, and the phase is 0. The second one is 0.125 minus 0.3 J. So this is the number in magnitude and in phase, and so on and so forth, and you will get, so this is, I'll plot the magnitude and the phase here, and you will see the second element is 0.32, which is the magnitude here. The phase is minus 1.178, which is here. And you can see that this is the magnitude plot and this is the phase plot. The horizontal axis is k from 0 to 7, and this plot is the magnitude plot, this plot is a phase plot. And we are done for DTFS of 8 samples.